So in this example, we would like to test whether the actual mean weight of packages of green peas is different from the printed weight of 340 grams on the package. So our null hypothesis here is, the hypothesis of no difference. That is, we will assume that the mean is actually 340 grams. And alternative is what? Alternative is, it's saying we are testing whether it is different. So different means we'll just put it as mu is not equal to 340 grams. All right. So say I selected a simple random sample of 10 packages and weighed them, and the data of the weights of those 10 packages are here below, and they are given in grams. Okay, so now our sample size is small and we are going to use the t-test because we don't know the population standard deviation here. And since we have only 10 items in our sample, it'll be a good idea to look for any outliers in the data. So let's make a box plot, which you can write the 5-number summary and use it to make the box plot. So here is a box plot of the data based on 5-number summary, and it doesn't show any strong skewness. So we can go ahead with our one sample t-test procedure. So we are using our TI-84 calculator for the purpose. So first thing we have to do is that we have to enter the data. Okay, so to enter the data, what we have to do is we have to, again, let me go back. So we go to stat, we are doing statistics, and we are going to edit a column because we don't have summary statistics here. Now I already have data in here, so I can either use a new column or I can just go ahead and clear the data, which I'm going to do because I don't think I need it. So, and then I shall just enter the numbers, and I'm going to come back after I am done entering all the numbers. Okay, so you can see I have entered all the data in the column L1. So now I will go to stat, go to tests, and we are using the t-test here. Okay, so we select that, and we use this stats column when we have the summary statistics given. Since we don't have the summary statistics here, so we shall choose data as written here. So what is our null hypothesis? The null hypothesis is 340 grams. And it's asking me where the data is. So our data is in the list L1, remember that? And if we put that in some other column, then we would just go ahead and select that column. And frequency, we are going to leave it as 1 because we entered every number just once. In this case, it was just by chance that all of them are different, but we didn't make a frequency distribution. So anyways, if you just enter all the numbers individually, you will leave the frequency as 1, and then our alternative is not equal to. So we will go ahead and ask it to just calculate the values by using the data that we have. Okay, so what we get here, we got this now, that we have the t statistic is 3.9, right? Okay, so this is our test statistic, right? Okay, so our t statistic is, this is the test statistic. The question sometimes asks for it. Okay, and you can see it's a kind of large test statistic, and then this is the p-value. Okay, and the p-value is how much? 0.0 it's 0.004 about, okay, and so it's a very small p-value, so we will reject the null, and you will say that it is different. Now it was not given in here, but say we were given that the level of significance is 1%. So even at 1%, we have a significant evidence here. All right. So now what I'm going to show you is this, that when our alternative is not equal to, a confidence interval will also support the same conclusion, a related one. That is, if the level of significance is 1%, then we shall construct a 99% confidence interval. So what we are doing is, let us construct a 99% confidence interval for the population mean. All right. So what we would do now is we'll go to stat tests. Okay. Excuse me. And remember, our t interval is this number 8. And again, we are using the same data, so we'll leave everything as it is. Let's change the confidence level to 0.99. Then let's ask it to calculate it. All right. So you have, you got the confidence interval as what? So the confidence interval is 342.31 grams to how much? 365.49 grams, right? So you can see this here, that our hypothesis test at 1% significance level rejects the mean value of 340 grams, and this 99% confidence interval, right, interval excludes, okay, the 340 gram as the value of population mean. All right. Let me know if you have any more questions. All right, I'll try to answer it. Okay.